switch to the next session right now. And we always need something to explain the change from one session to the other. I had brought something because it was the first time that I could join the passion I have with my job. So we'll have a great presentation for 3 projects, one project in Norway, other projects in Peru, and then we have other projects that are international but are settled in Barcelona. So in some way, I wanted to do what I do every time there's a Barça game. And it's great that I have this opportunity today. I can do it with BIM today. Also, like all the great players, Neymar, Messi, I wrote something, EU BIM Summit. So,
there will be very, very nice projects to see right now.
Thank you. Thank you. Good afternoon, ladies and gentlemen. I'm Tim Broyd from University College in London, but here speaking later, so there will be a lock-in. I'm due to speak about 7:15 on behalf of the Institution of Civil Engineers. This is the second session of case studies. As you'll see, there are 4 people, but there are only 3 presentations. So what that'll mean, I'm not sure. I mean, I've seen all of the presentations, but it's my bad luck that they're all in Spanish. Now, that's fair, of course. We're in Spain, after all. But then my knowledge of Spanish extends only to ordering a beer, and even then I sometimes end up with a glass of red wine. This will be a very light touch coordination, and I think you'll perhaps be pleased with that. The first presentation then is from Magnus Vage from Mestres Vage Architects. He's based in Norway, with the other presenter being Maria Mestres. Well, I think you can guess which company she comes from, but I have an idea she's based in Spain. I will leave it to the speakers to introduce themselves, because otherwise I will get it wrong. Thank you.
Thank you for your introduction. We are Mestres Vage Arquitectas. I think we're an example here today because we are a small architecture practice. And we need to do a lot of collaboration, so that's why the title of this presentation is Collaborative Design in our practice. A little BIM team, that's the title. One important thing for us and also for our job, our profession, is a change that hasn't really arrived in Spain yet. However, the situations we've worked on, mainly in Norway, are quite different from Spain, because we see there's been a change in the profession. This circle represents all the stakeholders in an architecture project in Norway. As you see, the architect is only one of the stakeholders that need to participate in the project. And we need tools that we can share with the other stakeholders. For example, in Spain, up until now, many times the organizational chart is based on having the architect as responsible of the contract, and then he searches for the other professional stakeholders that take part into the project. In our case, it's completely different. There are different contracts and they have different responsibilities. So, for example, we have the person in charge of facilities signing their own constructor, the person in charge of structures as well, but there's constant communication with the user. Another important aspect here is that 70% of the practices in our profession have only 10 people working on them, or even fewer people. So we represent a large part of our sector. In our practice, we work architecture and urban planning as common disciplines, and we offer different services that go from conceptual design to works management. We have implemented BIM in the first stage and up to the last one. Our values, you can see them here on screen. I think the last one is the most important one. Within this context, we believe in an open architecture that is inclusive, geared towards the user, that can be adapted, and we do the projects thinking of the building life cycle. When we say open and inclusive, means that it's something elastic, but we also think whether we need tools that can offer transparency in some way. We are small, but with an international focus. We collaborate a lot with different architecture studios in Norway, and the same as happens in Finland. BIM in Norway is very different from BIM in Spain. We are more similar to BIM in Finland, for example. So in the first phase, when we want to obtain projects, we do a project. And I will talk about the advantages. Of course, there are some disadvantages as well, but I will talk about the advantages of using BIM. It allows us to have a more simple control of the program. We always need to work with the program, and we need to offer a proposal. We have also formal coordination and team coordination, and we see that BIM also improves transparency and consistency of the proposals we make. Also, when we are preparing the project in our architecture practice, in 2007 we started using this dialogue between all the hard data, the numbers that you need to meet to participate in the competition, volumes and so on. But then we have the dialogue with the views we are producing, and also the other information in the project. That allows us to know that what we are proposing and the images we show are related to what we are really creating, and that's really what the client is asking for. We have another example here. That's a proposal for a library in Helsinki. We have a proposal for, well, another project here. We have also post-production for images later on, of course, later on. But basically, these are different proposals we've made. So what I've shown is internal control when doing a project, but what we have learned lately is that sometimes the client wants to have the BIM model. So things change. You have competition, and the client wanted to have a model control with dialogues. And by this, the client can know if you are basically using what they are asking for. Maria will talk now about two projects that we are working on right now. Actually, the first one is finished for the Rocus, which is from a competition we won in 2010. And then the second one is an extension of a hospital. Hello, good afternoon. For the first project, basically, we worked for local administration, and they had never heard about BIM. So the team of architects suggested to use BIM for coordination. The second cause on the right is very different. It's a hospital that belongs to a wider national organization, and that was a demand from the client. We had to use BIM. In the first case, we stayed in the volumetric coordination and management, and in the right one, we are going to try to achieve lot 500. In the first case, we were only involved in so basically only the technical profiles were involved in the BIM project. Now, on the right, we have also the property, and we expect that the construction company that won the competition will also use BIM. As Magnus said, in Norway, there's another structure, and each discipline has its own contract with the client. So it's good that each discipline has their model, because, you know, the legal responsibilities are well defined. And basically, we work with three main coordinated models, and we see that each planner worked with the central model. That allowed us to have delocalized groups, for example, some in Barcelona, some in Norway, you know, in a very remote place in Norway. That allowed us to work together. And that was good, because we could control everything on a daily basis without having to be physically at the same place. In this project, we use the same system, but we use different technology that is faster, actually. What we have improved, though, is in the VEP, the work manual writing for the BIM execution plan. We have done a brief and very specific document so that people can read them and get hands-on on work. With the VEP, we see that it's important to define why we want to use BIM and what requirements we have, what BIM strategy is we are going to follow, if there are public requirements like in England, or if there are, and we need also to define what standards we are going to use. We use the standard from the contractor sector in Norway. Also, there are definitions. We assign roles, and we assign also the requirements. We have very evident things here. For example, I don't know, for example, the origin of the project, what levels. We also deal with naming of the objects, alphanumeric. We don't use the Omni-class classification, we use a Norwegian classification, and this is one of the pillars to work properly all together. We also need good communication, and that means that every project has a transparent web for all the members of the team. The calendar is clear, everyone has access to that. All the decisions regarding design are also available for everyone. So every agent participating in design can read these things. All the work in progress documents are also available. The working process is also defined, and we know who uploads the project into the cloud so that it is ready for the coordination meeting, and then we can go implement the changes and do the same process over and over. it is also important to define what programs we are going to use to work, because sometimes, of course, they are not compatible. And the file structure is also important, because we live in an imperfect world. And, well, the perfect BIM does not exist either. We have a lot of information coming from reports or from CAD. And the input and the output, well, they need to have a structure that will allow every kind of information to be part of it. In white you can see the files, and we got as many ISFs as native formats, and we got to 2D CADs. Because, for example, one of the members could not use another thing. Here we have a view from Solibri, the program that we use in our working meetings. You can see the facilities here, also some construction elements. And here we have some confrontation between architecture and facilities. This is another program we use. This is a program used by people who do not really know about CAD. It's the Rufus. For example, in the hospital we have standard rooms. They are the same throughout all the country, so we can reuse the information from previous projects and use it in our building. We can do, of course, some modifications, and we can create different rooms if we want to. This is important because people that do not know about modeling can do it.
Luego nosotros lo usamos y dentro del mismo programa de modelado podemos comprobar.
We use it and we can see whether the information from the property and our information actually match.
También lo hemos usado para hacer mediciones.
We have also used this to do some measurements, but we've had some problems, unluckily. And Skanska won the competition. They are the ones that are going to build the hospital, and we hope they will do what they said they would do. They will, because it's way better, yeah. We are saving paper here, right? They won't be working with obsolete documents if they use the ICF. And we know that the people working on the works will have the model, and they can work in 3D or to understand better what they are doing. So, just as a thought here, we're always thinking what we are obtaining by using BIM. And I think that up until now, we've seen that we spent pretty much the same time in our office working on the project. But what we've been able to do is taking some time that we devoted to production, to idea production. So we can do more research, we can come up with better ideas, and please don't reveal these because otherwise our salaries will go down. But the dream is that each project can have more attention from the architecture point of view. Thank you.
Thank you, Maria and Magnus. I think always one of the joys of simultaneous translation is that you get 2 goes of laughter at a joke. You get the immediate laughter with people in the native language being able to hear it, and then a couple of seconds later, and no criticism at all to translators. I think they do an absolutely superb job, but it is just a second or 2 later. Anyway, thank you very much. Our next speaker is David Cano from FC Barcelona. I haven't got a shirt to wear, but before he speaks, I do have three requests, really. Now, the EU government leaders are meeting today, so in a spirit of European harmony, I ask you, David, can you persuade Messi, Neymar and Suarez to leave Barcelona and join Crystal Palace? Now, they're sort of, my team's mid-table in the Premier League in the UK. We're not bad at the back, got reasonable midfield, but a bit short of firepower at the moment. If you can't do that, could you at least persuade them to stop scoring goals against English teams? And maybe the English national team. And I'm not proud. If you can't do either of those, then some free tickets would be nice. More seriously, David, I think, is going to speak to us on developing and implementing and using a BIM model of a large existing structure. That is, of course, the new camp.
Well, good afternoon, everyone, and thank you very much to the organizers that have allowed us to share our experience in Football Club Barcelona for the Espai Barça, and also thank you, Ignasi, for this joke or with this with the T-shirt. Well, I would like to focus on 3 different concepts, which I believe are quite relevant for the implementation of BIM methodology in Barça. First of all, the previous experience, or what we have found when we decided to implement BIM methodology and to incorporate it in our lives as a sports club. Secondly, to believe that BIM is more than a process. It's become part of the cooperative brand, and therefore we've called it more than BIM. That's a pun with the motto of the football club. And finally, I would like to talk about the lessons learned and the problems that we're facing on a daily basis. Well, first of all, I would like to give you some feedback, or some background of the Espai Barça project. Currently, is one of the most relevant building projects in the sports area at an international area. It's an investment of more than 600 million euros. And its main goal is the refurbishment of the Camp Nou stadium. As I said, we have, in parallel to that, different other projects which are quite interesting as well. You can see them on the pictures. We are extending the capacity of the stadium in 3,000 more seats. Also, the offices are being refurbished and so on. From the beginning, at our team, we believed that this project, which is very large, it makes sense. The BIM methodology makes sense for this project. Actually, when we started, we found a structure which goes back more than 60 years ago. And this structure has been adapted in a dynamic way, but also in an uncontrolled way. And we had very old information which was not real, was not corresponding to the real situation. So we weren't able to match the data that we had, and we really had to see the geometry which we didn't have. And therefore we decided to make a topographic study in 3D of the whole stadium with more than 5,000 scanner points. And with that we developed the model that you can see on the screen. besides that, we also incorporated a range of parameters. Here you can see some pictures of the model. And then we've got a video which we created about 8 months ago. And here it is explained the process, the developing process of this model and how this information is integrated. Good. So the video you just watched, it helped us a lot for the SPY Barça space, in order to show internally to the managing instances that BIM could be much more than a methodology in the design process that could be also exploited as a part of the brand. Well, how did we build this as-built? We had to gather knowledge on the real geometry. On the other hand, we developed a site project where we design all the seats of the stadium. We did geolocalizations of them, and we matched it against the database of members of the club, so you can see how powerful this is on a social level. We incorporated all the structural data. We had a consultant for that. We also incorporated all the visible facilities, and we are incorporating both the visible and underground facilities in the whole stadium, in order to avoid, well, some of the problems that I'm going to explain right away. This allows to have a deeper knowledge of our own infrastructure, and it's easier to minimize the risk. And on the other hand, this model has allowed us to estimate the costs in a much more precise way. The second point we saw very clearly within the team at SPY Barça was that this whole BIM thing, which is kind of difficult to grasp if you don't have any idea about it. It's difficult to understand if it's a technology, how to implement it into a project. We realized it was a huge opportunity for the football club in terms of commercial exploitation. And from then on, we decided, as something mandatory, that any stakeholder which would participate in the process should have minimum knowledge on BIM. They should be able to demonstrate some minimum or skills in BIM technology, but it's pretty obvious that any company, constructors that wants to work with us must be at ease with BIM. In this slide, I would like to present a summary of our organization. And as you can see, in all project units, both the architecture and engineering groups, we are demanding BIM knowledge. Also, for the project managers, we are demanding to integrate BIM management. And also at a consultant level, towards the client, we have a BIM management team in order to make this traceability possible. In this graphic, you can see the dedication of all teams that are participating in the BIM implementation. Actually, I think there's a quite clear phase within the project, which is the design and construction phase, and then there's a second phase, second stage, which has been developed in the past 6 months, which is management and exploitation of assets, which is now under the management of the club, the football club. So we are facing a project which does not only include building, but it has also cooperative components, and therefore the motto, more than BIM. So this philosophy can be summarized as BIM becoming a methodology for the football club. We also approach the database in a global way, but at the same time, we focus on the goals that we want to reach with the BIM methodology. For the football club, both in the construction and the exploitation stage, it's an as-built, a continuous as-built, and this will allow us to manage the whole facility in a more coordinated and controlled way, which is not possible right now. All this has some internal implications. In our strategic plan, there's this term, BIM culture. When we talk about BIM culture, there's a direct implication to different departments within the club. Some of them really need to work on that, and some others will have to integrate at a cross-sectional level. Internally, we are considering that as a technological innovation project. And finally, last but not least, the football club believes to be a leader not only in sports, which is of course true, but we also believe that's a way to boost the implementation of BIM methodology with this project at a local and regional and private level. Well, finally, I would like to talk about the lessons learned. What have we learned about this process over our journey? All these BIM implementation processes and so on. In the first place, I think that it's pretty obvious for many of you, but we were quite new in BIM methodology. We didn't have a clue about that. So we had to define if the as-built model should be an open code or not. Or if we should use instead a software, specific software. And so at that time we decide we went for the open format, and I think we made the right choice. And nowadays, I think it was the right thing to do because it allows us to scale the project. Secondly, it seems very easy, and I'm quite glad to be here today and see that so many people are developing projects like that in other countries. But when you are facing the BIM implementation for the first time and you try to grasp it, which is something quite complex, and you try to define all the tenders, all the processes, the BIM execution plan, the taxonomy, fundamentals in taxonomy, the parameters that should be used in the models, the degree of detail that you are going to use, it's not easy. It's not easy if you don't have a clue about what are you talking about. So something that really helped us to understand what we wanted to do were the trials within the us field allowed us to see what were we looking for and assess the consultants we were working with, because we weren't able to assess the people we were working with in written, because we didn't have the knowledge. Finally, we audit these models. I think also that was the right thing to do. And on the other hand, we audit them at an internal level and also with the final users, the end users. We send the models to the different stakeholders that were going to bid at the Camp Nou tender. Well, a BIM manager is not a project manager, and I would like to stress that, because from the customer side, we see that the language they use, or the language used by a BIM project manager, is quite complex. From the point of view of the customer, who has some goals and needs in the projects you are working with them, it is important to have this link, which is the project manager, and this person is going to establish the relationship, is going to make this relationship be more fluid in terms of the project managing. It is quite clear that as we had BIM as a part of our business strategy for the Barça, it's been a chance for the exploitation of equipments and infrastructure. Actually, we believe that it's highly recommended that any infrastructure or large infrastructure, sports facilities, hospitals, offices, and so on, BIM methodology really makes sense. And the last point is something that actually it's self-criticism, is that local market, especially in the building industry, we believe it's not prepared to go for large BIM projects. On the other hand, we think that at a local level, the learning curve that this learning curve that all of us are having is going to be quicker than in other countries. I hope so, at least. And our Finnish colleague was talking about the tornado, so I call it the tsunami, because tsunami is something that you don't know where it comes from. And actually, sticking to the tsunami thing, that would be a summary, is that the promoter, also both public and private, probably will ask, which are the benefits of BIM? How much does it cost? Does it mean an additional cost to the project? whom can I rely on? So we are learning. We are learning, and I say that it's not easy. We are learning while we are developing projects, and we learn from our mistakes. On the side of architectures, I think they had to change the design processes. The processes when embracing challenges. And of course, I believe that all people here already know that, but I think it's important to make this paradigm shift, not to see it as a deliverable, but as a tool, or the other way around, to see it as a deliverable and not as a tool. And I say that because it's a situation that we are facing on a daily basis where BIM is being implemented. Engineerings, I think that they do have some more knowledge and a more consolidated experience, especially in civil works, but we don't really know how are they going to integrate with the architecture models. And finally, project managers' teams, they have to focus on learn everything that surrounds BIM, especially from planning and cost estimation, but actually at local and national level, there are only few teams that have really implemented BIM for project managing. Well, optional managing, they should try to learn before the wave reaches them. So I have this feeling that they are really striving to see how are they going to apply it, how are they going to implement it. Construction companies, from my experience, having met many of them, and some of the most important of them, many of them are already implementing the BIM, even if the clients are not requesting that, because they really see the advantages, not only for the project, but for their own project management. Also, materials and equipment suppliers, I think they should be differentiated in the supply chain. And finally, all the consultants, BIM consultants, my feeling is that not everyone has had the chance to participate in large projects. It's not the same developing housing units than our football stadium. So it's a continuous learning. And also, in my opinion, we have seen some intrusivism, people from other fields that are taking advantage of the situation and are providing services which are not their expertise. Finally, 4 key concepts which we believe to be key for success. I always highlight common sense. I really defend BIM. I believe it's great, but we should have common sense. Until a few days ago, we were working without BIM. And sometimes we try to develop everything based on BIM. And this makes more difficult to have a clear traceability. Very important, a collaborative environment when developing a BIM project. And this not only means to have the best BIM consultant at your side, but this person must be willing to collaborate with the customer, with the engineers, and anywhere. Flexibility to make decisions, to focus clearly on the different goals without getting lost. without being too ambitious, as somebody was saying before. And finally, that all stakeholders see it today as a great chance in order to improve their professional careers. And I believe that that's a huge improvement for the industry. Thank you very much.
Tornadoes of BIM, we've had tsunamis of BIM. Now, I'm all for disruption, but they seem a bit destructive for me. I think I prefer a force that tends to do well for honest and hard-working people, and perhaps the opposite for dishonest and lazy people. So I'll offer up magicians of BIM. Anyway, we go from someone who I would guess has had one of the shortest journeys to get here today to someone who's had one of the longest, not the longest, but our third and final speaker is Felipe Quiroz, who is the founder and current technical director of ID and BIM from Peru. Felipe.
Tengo un problema. Tengo un problema con la.
I think I have a problem with the presentation. I cannot see it.
Si te decía que está en doble pantalla. Que está con doble pantalla.
No, no está enchufado. Ahora.
No, es que está en doble pantalla. Ya, ok. Bueno, buenas tardes.
Well, good afternoon. My name is Felipe Quiroz. I come all the way from Peru. I'm the technical director for ID and BIM. And I want to talk about BIM applied to production because I have experience in detail engineering, specifically for concrete, for 15 years with Reddit, Naviwork. I've been working with these programs for 4 years. But I will talk about the experience in Latin America, Chile, Argentina, Peru, and also past experiences in Europe to bring BIM to another level, not only in visualization, integration, and harmonization. In Peru right now, we basically use it for harmonization, but we want to bring it to the next level, to the production level. And that requires technology in order to model something. And we can do all the draftings, all the planning and everything, and we can create automatic machines. But before, I need to explain some things. In Peru, really, we don't really have the obligation to do detail engineering. I think it's the same in Spain. We build using a basic engineering drawing. That will have to change if we want to bring BIM to the scenario. We want to create every project with a graphic representation obtained from a model, and that's detail engineering. When we talk about virtual design construction, we see that in Peru, we use VDC to generate BIM models. But not only that, we want to move the project in the early stages so that we can have a positive impact in costs and we can do some economic assessments. How do we do this? Well, our company helps a designer, a construction company, an engineering company, and we help them. We look at what processes they follow, and then a process that they know, and then we tell them how they can include BIM models. And these models can be useful so that when we have ICE sessions, these models can be helpful to visualize, obtain all the metrics and indicators that will allow to optimize the project. These may look like common sense, but why aren't we actually implementing it? Well, basically, there's the time constraint, and basically most projects are done in 2D. So when we do the modeling in design and we want to bring it to construction, there's almost no time to bring that model into something that will actually be built. If we want to do that, we need to have the right tools, the right technology, and we want to, so that we can increase productivity. And we also need to have automation tools, but basically we need to understand the flow, the process that we're going to follow, and what indicators will be the ones that will tell us what to do. So when we create the drawing, we need to have these indicators that will basically tell us how we are doing with our task. So what we are proposing is a model where the builder will see the prototype before it goes into a real detail engineering drawing. That's the most important. We want to work as much as possible in the model so that we can turn that into a drawing or in a specification for building. Here I will show some examples of how we have done this in Chile, Argentina, and Peru, now also in France. And the first thing we see here is how BIM is used in the design stage. The problem we had is that here is that we had a tunnel. It was done in 2D drawings, but several aspects changed, like the gradient. So we used, for example, the client used AutoCAD for basic engineering, and then we couldn't really change it. They were going to do the AutoCAD drawings. But the data we obtained from the drawings, we had to convert it to a model, and we used Tekla for that. The client used some Excel sheets to include all the typical sections of the tunnel, and every time that the AutoCAD drawing changed, also implemented the changes automatically in the Excel sheet. And afterwards, the Tekla tool read these drawings to generate the model for the tunnel. Here you can see how the elements are placed into the drawing. And why did we do that? Well, because the changes would happen many times. So every time that there were changes, we didn't do the model all over again. And therefore, the client won't want to use 2D. They will want to use BIM because it's way faster. That's basically the idea behind. BIM is faster. We also used ICF so that we could combine specialties. For example, here we had models done with Reddit, and we joined them with Navisworks, and we worked in a collaborative way. Also, regarding design, what we do is, before we place the reinforcements, for example, we verify that all the concrete is compatible, and then we define whether there should be some openings and so on. So we use this tool to import reference models with Reddit, and then we work our structure in Tekla. We can use also drawings as a reference model. We also work with the reinforcements, and based on our experience allows us to do any structural component in any way. When we only have the model with the reinforcements, we can have images like the ones, reports like the one on the right, and we can modify the design to obtain standard measures. Therefore, we can reduce the amount of steel in the different varieties that we need to use. So we see some benefit already. Nowadays, this service has an additional cost, but if we use it rightly, it's worth it. Also, it's very important to have a catalog and a structured catalog, and that means naming all the elements we will build and also set a due date for fabrication and manufacturing, basically, and delivery. Everything needs to be named. Then we can decide who will be in charge of that drawing or when. It can be a simple building or a complex work, like an energy plant. The main thing is not in BIM. We need to define the flow, the name of the elements, and that they have a constructive sequence. Thanks to BIM, we can verify the constructability of the elements, either sketch or input from the builder, to see if we need to change the basic model to something more complex. We need to do all these things only in the model. And after doing these collaborative meetings, we get the drawings. We'll see another brief video on how, in a simple example here, we use Tekla for this recreation. And we will show here how this element, we see some interferences between the profile and steel, but also we will see how this piece is built. This project, for example, is done in France, and no bars could really collide. So thanks to this representation, we see that there is some collision, for example, in the beam reinforcement, and we see it's colliding with the profile. So the designer basically said we can move one bar to the side, and it was approved. So this saves a lot of time that is wasted in the works, because, for example, if that happens in real life, we need to stop the project, do some queries. But if we work with this technology, we save this time. So basically, we created a beam with steel. Well, moving forward, we are still in the pre-construction phase. We also detect other aspects We do some templates so that it's faster to build some elements in the work site. We want to avoid interferences, and the software is ready to detect all these things so that whoever knows how to do this can give the answer. In this case would be the builder. We also need to define what elements are going to be prefabricated, because in the original design we don't have it. If at the beginning we do a project with BIM, Tekla, Revit, when we bring it to real building, it will change, because it has to change in order to build it. And the builder will bring his input to the table. We need to be flexible in order we can change all these things if the changes come from a person who knows what they are talking about. Then we have 4D simulations. It's just a presentation of the elements we are working on. It's basically to show what we are doing. But if we want to know exactly how something is going to be done, we need more than a 4D representation. We need to modify the design, but we need to make it buildable. Once that we approve how we're going to do something, we stick to it and we do the drawings. Drawings can be the same as we obtain with AutoCAD. We have many different kind of drawings, different formats. And currently we can do that thanks to technology. Some years ago it was very hard. Nowadays, for example, we work with Tekla that allows us to export drawings, and we can import that to AutoCAD, including all the layers and all the line vectors, so that it follows the client's and customers' standards or the project that we are working on. This is the drawing environment for Tekla. It basically saves all the settings so that it can do the drawings. Basically, Tekla shows what the model has. It can take as much time as doing it in AutoCAD, but when we have to implement a change, it implements it automatically. So basically, using BIM doesn't mean that, the drawing is already done. No, it will take more time, but then changes are implemented automatically. But if you do models, then it can be faster. Here we can see how the drawing is exported in AutoCAD. We have all the layers. And we see how it is exported in PDF format, or any kind of drawing we want. When do we see a difference regarding the amount of time? Well, it applies to automation. For example, we have a project in Argentina where we had many drawings for basis, but he did some sketches. He didn't do some basic engineering drawing. So basically, the person in charge of the calculations did some sketches and used some Excel sheets where he put all the values. He gave us that information, and together we defined a form where we included the geometric information and also structural information. That's what we are seeing on screen. Then the client filled in the information. He had a structure catalog and just filled in the gaps. That's when it becomes automatic, and that's the difference between the traditional method and BIM, because just by placing the information, you have the automation and the model is automatically generated, and also the drawing. So you have the model and the plan and the drawing automatically. So timing is very different between the traditional method and the BIM, but you need to have the right structure to do so. When we have a project, first we need to think what we can do with this automatic way, and then we do the rest with manual tools. The BIM fabrication means, well, I'm actually skipping this. Tomorrow we are going to have a workshop with Celsa. Some years ago we saw the way Celsa worked, and we have been able to replicate what they do in Nordic countries. Basically, they do modeling, and they work with a metal company. And even if the client hasn't asked for BIM, they can offer him or her an automatic process. In this case here, it was a bridge in Peru, and the information of the model was developed so it could be imported into the Jordao format. This information was directly implemented in the system, and the client could read all the information from each bar. And that transfer of information was automatic. And also then they used their automatic machines, and they built the steel from the model in their facilities. So since last year, we're already doing this, and we are obtaining good results, because what we are modeling has been always manually manufactured, but now if the model is good, it can be automatic. Of course, there's some verification step, but it's working. And just to finish my presentation, how this model can become real. How can I help with productivity? So we use Tecla Insight in all our projects so that we could not only give the drawing. For example, on the left, we can imagine it's a tablet. And what we do basically is we clean each drawing on the right, which are PDF drawings. And each of these drawings appears on the list I'm pointing at right now. And if I select a drawing, it will show the different levels, the base, the reinforcements. And each drawing comes with its model, and it has the same name. So when I want to build something, I will look at the model, and I will tell the worker what they are going to do. We have a 2D drawing here. It contains information that sometimes is not understood, but if before the building stage we have a meeting with the workers and I show them what they are going to build, it helps them greatly and it increases productivity. For example, we have this drawing. It's a 2D drawing, and then if we filter it in the tablet I was mentioning, we have this 3D drawing, and I show it to the worker, and then the worker knows what he's going to do. If he only looked at the right, he would have no idea. So on the left, I can mark pieces and elements in the model because there's traceability. However, in order to do so, I had to thought of the catalog and think of how the model was going to be done. And this is basically what I wanted to show, where we are working at in Latin America and also in Europe. And that's it. Thank you very much for your time.